Welcome back. This is Advanced Geometry with Mrs. RRubright. Today's lesson is 11.4, Geometric Probability. Alright, so our first problem, find the probability that a point chosen at random on PQ, on segment PQ, is on segment RS. So let's see, how long is segment PQ? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's out of 10, and what portion of 10 is RS? 1, 2, 3, 4, 5, 6. So 6 out of 10 reduces to 3 over 5. 3 over 5 is 60%, or 0.6. Part over whole, what you want out of everything. A monorail runs every 12 minutes. The ride from the station near your home to the station near your work takes 9 minutes. One morning, you arrive at the station near your home at 8:46. You want to get to the station near your work by 8:58. What is the probability that you will get there by 8:58? So it says you arrive at 8:46. So it runs every 12 minutes. So it could get there at 46. If it got there at 8:46, that puts you at work at 9 minutes later would be 55. If it got there at 47, 48, 49, 50, 51, 52, 53, and so on. Okay, so if it got there at 47, you get to work at 56, 57, 58. So you need to get there by 58. So it has to come within the first 1, 2, 3 minutes, right, of you being there. What is the probability that you'll get there? Okay. So 1, 2, 3, so it's going to be 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes, 7 minutes, 8, 9, 10, 11, 12, right? That's the amount of time that it could take to get there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But only 1, 2, 3 out of the 12 is going to be possible for you to get to work on time. 3 out of 12 reduces to 1 out of 4, 0.25. You have a 25% chance of getting to work on time. In example 2, suppose you arrive at the station near your home at 8:43. What is the probability that you'll get to the station near your work by 8:58? All right, so if you got there 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It'll definitely be there by 8:55 because it's every 12 minutes. And it takes 9 minutes to get to work. So 8:43 will put you at work at 8:52. 53, 54, 55, 56, 57, 58. We need to get there by 8:58. So we have 1, 2, 3, 4, 5, 6 minutes out of 12 minutes that'll get us to work on time. We have 1/2. When we divide by 6 on top and bottom, it reduces to 1/2, 0.5 or 50% chance of getting to work on time. Find the probability that a point chosen at random on PQ, on segment PQ, is on the given segment. Express your answer as a fraction, a decimal, and a percent. All right, so segment RT. On PQ. Well, how long is PQ? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's out of 10. So RT out of 10, so that's 1. 1 out of 10, 0.1, 10%. To go from a decimal to a percent, you move 2 places towards the percent sign and add a percent sign. 1/10, 0.1, 10%. TS. 1, 2, 3, 4, 5. 5 out of 10 reduces to 1 out of 2, which is 0.5. Move it over twice, it's 50%. Move it 2 places towards the percent sign and add a percent sign. Find the probability that a point chosen at random on PQ is on the given segment. All right, so let's see. PQ. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's still 10. And what does it want us to do? PT. So that's going to be 1, 2, 3, 4. 4 out of 10 is going to be 2 over 5, which is 0.4 or 40%. And our next one, RQ. 1, 2, 3, 4, 5, 6, 7. 7 out of 10, 0.7, 70%. The diameter of the target shown at the right is 80 centimeters. The diameter of the red circle on the target is 16 centimeters. An arrow is shot and hits the target. If the arrow is equally likely to land on any point on the target, what is the probability that it lands in the red circle? So it said that the red circle has a diameter of 16. It says that the diameter of the entire target is 80. Okay, so probability of red. So what we want, it's what you want out of everything. So what you want is red, the area of red. Pi r squared. If the diameter is 16, the radius is 8. It's half that. 8 squared is 64. So 64 pi out of the whole possibility. If the diameter is 80, the radius is 40. 40 squared, pi r squared. 40 squared is 1600 pi. The pi's cancel out. 64 over 1600 is going to reduce to 32 over 800, and then 32 over 800 is going to reduce to 1/25th. So it's going to be 1 over 25, which as a decimal is going to give me 0.04 or 4%, because move your decimal 2 places towards your percent sign and add the percent sign, it's 4%. You have a 4% chance of hitting the red circle. In the target in example 3, each ring is 8 centimeters wide. Find the probability that an arrow lands in the black region. So for this one, you would need, okay, if each of these rings is 8 centimeters wide, 8, 8, 8, 8, and then over here in the center, I believe they said it was 16, right? It was 16. So it's going to be another 8 for that radius there. So for it to land in the black region, we can take the whole circle, the whole large circle, which is 8, 16, 32, 40, right? It was a diameter of 40, or sorry, a radius of 40. 40 squared pi, pi r squared, minus what's missing. Well, what's missing? We're going to take the whole thing minus this white one, which has a diameter of 8 times 8 times 8 times 8, or sorry, 8 plus 8 plus 8 plus 8, so 1632, minus 32 squared pi, and then plus, so we're taking away this white circle. Now we're going to do this circle right here, the whole thing, which would be 8, 16, 24. So that's going to be 24 squared pi minus what's missing from that one, which is this white and red one together, which is 16 squared pi. So now with my calculator, 40 squared, so we have 1600 pi minus 1024 pi plus 576 pi minus 256 pi. So negative 256 plus 576 minus 1024 plus 1600 is going to give me 896 pi, and that's the answer in terms of pi, times the pi button. We're going to get approximately 2,814.9. Okay, so that is, oh, what was I doing though? Sorry. That's the area of the black. That's what we want. That's what we want. So I'm going to store this in 1. And that's out of everything. So divide that by the total large circle, the entire thing, which is 1,600 pi. So take that, divided by parentheses, 1,600 times pi, parentheses, equals, and we get 0.56. 0.56, which is 56%. All right, so the black rings, those 2 black rings, is 56% of the entire thing. And once again, how I did that is I found the area of everything minus the area of all this would give me just that exterior black ring, plus the area of this whole amount minus the area here that's missing from that smaller black circle. And that gives us those 2 black rings. That is what we want, the numerator, divided by everything for the denominator. All right, so your dog dropped a ball in the park. A scale drawing of the park is shown. If the ball is equally likely to be anywhere in the park, estimate the probability that it is in the field. All right, so the field, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, right? 3 by 10, 30. So what do we want? We want the field out of everything. 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 58-ish. So 30 out of 58, 30 divided by 58-ish is going to give me 0.517. Which is approximately 52%. So they got 52 squares plus these. They got 58.8 squares. So they did 30 out of 58.5. So they got 20 out of 39. They got 51.3. We got 51.7. It's never going to be exact, and that's okay. We both got very similar answers, and this is just an estimation, so it's completely valid. So they got 51.3, we got 51.7, and that's completely fine. You're just estimating. Well, that is the end of our lesson on 11.4, Geometric Probability. We hope you enjoyed the lesson. Please like and subscribe and have a great night.